In this video, we're going to do a couple examples where we use the definition of a one-to-one function to determine whether the function is one-to-one. So in our first example, we have f of x equals 2x minus 3. So basically, we want to show that if f of a equals f of b, then we can then say that a then equals b. So here we want to assume f of a equals f of b, and we're going to use that to prove that a equals b. So to start off, we're going to replace our x in this first one with an a, so we're going to have 2a minus 3, and we're going to set that equal to 2b minus 3, because for a one-to-one function to happen, in order for the f of a to equal the f of b, it only works if your a and your b are the same thing. So once we get to this point here, we've replaced our x with a and with b. Now we're essentially going to just try and solve and get the a and the b by itself. So we'll start off by adding 3 to both sides to get rid of that 3. And that's going to leave us with a 2a is equal to a 2b. From here, we'll divide both sides by 2. And we're going to see that in this instance, a, in fact, does equal b. So because f of a equals f of b implies that a equals b, we can then say that f is a one-to-one function. Let's take a look at our second example. Here we have f of x equals x squared plus 1. So we're going to start this problem the same way we started the last one. We're going to replace our x with an a and with a b, and then we're going to try and solve. So I'm going to begin by subtracting 1 from each side, and that leaves me with an a squared equal to a b squared. From here, I'm going to square root both sides. And when we square root, a common misconception is like, oh, I can cross these out and I just get a equals b. That does not work. Because when we're taking the square root of a variable, what ends up happening is I end up with 2 answers. So I'm going to have a equals plus or minus b here. Plus or minus b. So it doesn't always imply that you're going to have a equals b. So we cannot say that f is one-to-one. So again, because our f of a set equal to f of b does not necessarily imply that a equals b, you cannot say f is one-to-one. Therefore, f is not one-to-one. So you have to be really, really careful in your algebra there. And to show a quick example of why this wouldn't work, let's say that we use the x equals a 2 and a negative 2, or not necessarily x, but let's say a and b. Let's say that a equals 2 and b equals negative 2. So if I plug that in, and I have 2 squared plus 1, and I have negative 2 squared plus 1, notice that for each one I get a 5. And so, yeah, my f of a and my f of b were the same, but my a and my b values, they weren't the same. So hence, my function is not one-to-one.